Hello everyone, welcome to our group project in Math 123. Our title is The Application of Mathematically Modeling in Transportation Planning. The traditional transportation planning is to increase the roads in the premise that the vehicles constantly increase in order to minimize the vehicle's static average density and realize small transportation. However, with the development of the economy and the improvement of car production technology, the growth rate of the road cannot keep up with the growth rate of the vehicle on the road, which has led the increasing of the vehicle's static average density year by year. Therefore, the idea that the more roads will bring transportation convenience is wrong. If the government does not control the total number of vehicles, just increase investment in the construction of road and bridge, the transportation congestion problem will not be solved. That reduces the vehicle's average static density is the essential condition that ensures the smooth flow of the whole city roads. Here is a conceptual explanation of the mathematical being used, including its assumption. Here is the model. The mathematical model about transportation planning is provided in the following. The model has included all key factors in the urban transportation: people, vehicle, road, resources, and the environment. The linear planning model's explanation for road transportation planning is to obtain the optimally feasible solutions of the linear planning problem, which is the amount and types of transportation tools. Under the current population and road condition, namely B1 and B2 unknown, the vehicle can quickly and safely drive, namely number 3 formula is established, can fully meet the traffic demand of the public, namely number 2 formula is established, and realized at the least resource consumption and environmental pollution, namely the F is the minimum. When the population increases, B1 increases accordingly. The solution to the problem is in the following. To simplify the calculation, we have divided the transportation tools into the motor vehicles and non-motor vehicles. The motor vehicles represented by the bus are expressed as X1, and non-motor vehicles represented by bike are expressed as X2. The model is transformed into the following formula, and then the following set of experimental data is provided. Assuming C1 equals 50,000, C2 equals 10, A11 equals 50, A12 equals 1, B1 equals 3 million, A21 equals 100, A22 equals 5, B2 equals 10 million. The solved optimally feasible solution is X1 equals 0, X2 equals 3 million. Compare the slope minus C1 over C2 minus A11 over A12 minus A21 over A22. It can be seen that the optimally feasible solution X1 equals 0 and X2 equals B1 are very stable for C1, C2 and B1, B2. From the view saving energy and environment as transportation tools, bicycles is the best choice, but the bicycle has this disadvantage, such a slow speed requiring the self-drive. Therefore, it can be seen that it is not feasible that takes the bicycle as the only option. Continuing the above research, now we assume the non-motor vehicle number has been decided and is 2 million. The factor of non-motor vehicle is removed and only the motor vehicle has been left. And then further we divide the motor vehicles into large motor vehicles, represented by the bus and expressed as X11, and small motor vehicles represented by car and expressed as X12. Now the model is transformed into the following formula. The following experimental data set is provided. Assuming C1 equals 50,000, C2 equals 50,000, E11 equals 50, E12 equals 1, E12 21 equals 100, N22 equals 50. The solved optimally feasible solution is x11 equals 20,000, x12 equals 0. By comparing the slope minus C1 over C2 minus A11 over A12 minus A21 over A22, it can be seen that the optimally feasible solution x11 equals 20,000, x12 equals 0 is very stable for C1, C2, B1, B2. Therefore, the bus and bicycle are the optimal choice. Therefore, in the cities with transportation jams, the optimal choice of the transportation is bicycles and large motor vehicles. They will save resources, protect resource and environment, maintain the big city's traffic flow and the transportation's sustainable development, and create the better city. On the basis of the optimal selection of transportation tools, implement the network operation of the motor vehicle combined with the modern transportation management methods, and thus the transportation problem of the big city will be solved. Thanks, that's all.